morning.
I hope you are fine.
Fine.
Today, we are going to look at what is called differential calculus. I think many of you, or most of you, have did calculus when you were in your secondary school level about differentiation and integration. Now, in this level, we are going to do it further from where we left in high school. And at the end of this session, now, when you're in high school, you are taught about, let's say, a function. You are being given a function y equals to 2x squared plus 3x plus 3. Then you are being told to differentiate. When you want to differentiate a function, you use what is called standard differentiation. That is y equals to, say, ax raised to n. When you differentiate dy, dx, you use na x n minus 1. This is what you learn about standard differentiation in high school. Now, in this session, first of all, you need to understand what is called a function notation. When you look at this equation, y equals to 2x squared plus 3x, it means that a variable y is depending on a variable x, either directly or indirectly. That is why I can write y depends either directly or indirectly with x. This means that y is actually equals to a constant f of x, meaning I can be able to write y as f of x, meaning I can say f of x is equals to the whole of this function. Right?
Yes.
Now, let's go back to a Cartesian plane. Then you draw this line. So, when you draw this equation on this Cartesian plane, you'll be able to get a curve. And this curve is 2x squared plus 3x plus 3. Now consider 2 points, P, Q, and P. Then you draw a tangent to this curve from this point. You draw a tangent line to a curve 2x squared plus 3x plus 3. Are we together? Yes. After drawing the curve, you form something like a triangle, a right angle triangle. Now, for you to be able to get the slope of this triangle, you have to say it's a change in x over a change in y, right? Because dy dx is actually equals to the slope. And that slope is the derivative. Now, for me to be able, this point P has a coordinate xy, and this one, a coordinate x plus a small change in y plus a small change in. I explain how it comes. Then we consider from this to here, y is f of x. From here to here is x. Then here is now f of x plus small change in y. Now, for me to be able to get my slope, it's actually dy dx. It's actually changing y over changing x. You can just do it and say changing y, it's y plus, right, minus y over x plus minus x. This is equals to changing y over change in x. How does it mean? A small change in y. It means I have to take the length, the first length, change in y, x plus a small change in x, and then you know f of x, function notation. So you say dy dx is actually equals to the limit. We are going to first principle. A small change, as this small change in x tends to 0, then you open the bracket, a function plus this one minus f of x divided by small change in x. This is what is called the first principle formula. Right?
Yes.
7 minutes later. So,